Hello, my name is Professor Rad, and in this video, we will be analyzing a conic section. This will be our first example. We're going to do 3 of them, but I broke them up into 3 separate videos, so you can refer to them more easily than if they were all together in one. So this is going to be probably the easiest example we do, and then they're going to scale up in difficulty after that. So the most challenging part for me of these is getting the equation into the appropriate form. And then once you have the form, you can identify all these lovely features about the conic. So we're going to start out, this is our equation here. And what we want to do is we want to get it into one of our forms that we know about. So this is either we want it to be in the shape of a parabola, the shape of an ellipse, or the shape of a hyperbola. So when I'm looking at this equation right to start out with, I know this is going to be hyperbola. So I know that because I've already got features of the hyperbola shape showing up. So I have both the y piece being squared and the x piece being squared. So that's telling me it's either an ellipse or hyperbola. If I have a parabola, only one of them is squared, the other one is not. And then because we have subtraction going on, that means that it's going to be hyperbola. If I had addition here, that would mean it would be an ellipse. So the only thing that's really missing, you might think it's that this 9 and this 4 are here, but that's actually not the problem. Because if, for example, if a was 1/9, then y minus 2 squared over a 9th would be the same as 9 times y minus 2 being squared. What's really stopping us is the fact that they are not equal to 1. So I'm going to start out by making this all equal to 1 by dividing by 36. So once you identify you have either an ellipse or hyperbola, that's one of the things you want to be looking for. So I'm going to divide both sides by 36. So I'm going to have 9y minus 2 squared. That'll be over 36 minus 4 times x plus 5 squared. That's going to be over 36. And then this will equal 1. And then once I have that, I'm going to simplify those fractions. In particular, I'm going to rewrite it so that even if I had like 1/9, it would be all in the denominator. So 9, however, goes into 36 4 times. So we end up with y minus 2 squared over 4 minus x plus 5 squared, and 4 goes into 36 9 times. That's equal to 1. And I could stop here, but I'm actually going to take it one step further just to help me identify important information. And that's to write the bottom as being squared. So y minus 2 squared over the square root of 4 is 2. So instead of 4, I'm going to write that as 2 squared. And then this will be x plus 5 squared. And then the square root of 9 is 3. So I'm going to write that as 3 squared. Whoops. Actually put the right code in here. Okay. There we go. Okay, feeling better now. Okay, so that's our format for our equation. So now it does look like a hyperbola that we know and love, or don't love, but will survive with. So for the type of conic section, we can tell this is going to be a hyperbola. And easiest things to identify are A, B, and the center. So A on a hyperbola comes first. So A is 2 and B is 3. That's why I like to write these as a number squared, because otherwise I might make a mistake and say that A is 4 and B is 9. So just be careful about that. And then HK is our center. And remember, we're subtracting H and subtracting K. So that means H is -5 and K is 2. So we have -5 and K is 2. Now, from here, I just listed all the different types of things that we could have. So now I'm going to get rid of the things that are irrelevant. So a hyperbola doesn't have a directrix, AOS, latus rectum, or these axes here. So let's just get rid of those pieces. So we now still have to figure out the foci and the vertices. We have to figure out the transversal and the conjugate axis, the asymptotes, and C. So there are a couple of different ways that you can go about doing this. I like to do a mixture of algebra and graphing at the same time. So what I'm going to do is I'm going to graph what I know so far. So I have -5, 2 is the center. So I've got my little graphing pieces here, and I already forgot what it was, -5, 2. So I'm going to go over to -5, 2 and graph my center. Now I won't need this because I'm not making an ellipse. There we go. Now I also know some other information. In particular, I know how to find the vertices. So I know how to find the vertices because I have the center and A. So now I just have to figure out, are my vertices going to be up and down, or are they going to be left and right? That's one of the challenging parts of this next stage. So to figure out whether I need to go up or down, I come to my equation and I see which variable is first. So in this case, y, the y piece is first. So that means this is a hyperbola that opens up and down. So that means for my vertices, I'm going to go up and down from the center. So because A is 2, that means I'm going to start at the center. I'm going to go 2 up and 2 down, and that will be where I plot my vertices. So let's grab some points here. I'm going to go 2 spaces up, and then 2 spaces down. So those will be my vertices. And then once I have them graphed, now I can see the coordinates of them more easily. So they're at -5, 0 and -5, 4. So my vertices are -5, 0 and -5, 4. So this is one of those times where if you remember all of those other formulas that were on the reference sheet, in addition to the main formula here, you would be able to use that here. So you would have H is the same for both of these, and then K would be, the Y value here would be K plus or minus 2. Okay, so 2 minus 2 is 0, 2 plus 2 is 4. Like I said, I like to kind of graph things and kind of go from there. This is also going to help me find my transversal and conjugate axes. So the transversal goes through all the important stuff. So I can go ahead and graph that if I wanted to. So that's going to be a vertical line going through, it looks like -5. Let's go ahead and shift that there. So x equals -5 is the transversal. And then for the conjugate axis, it goes through the center, but in the other direction. So it's going to be y equals 2. Y equals 2 is the conjugate axis. Nice. I'm still missing the foci, and in order to graph the foci or to find the foci, I need to know C, which I don't know, so I'm going to hold off on that for a minute. For the asymptotes, I need to know A and B, which I do know. So for the asymptotes, in this case, A is the rise, so that means B is going to be the run. If my vertices had been to the sides, that would mean A is the run, so B would have been the rise. Oops, I want to copy it. So let's go ahead and graph the asymptotes. So A was the rise of 2, B is going to be a run of 3. So let's go ahead and from the center, we go up 2 and then over 1, 2, 3. Apologize if you hear my cat howling in the distance. He's sad because he wants to go play outside, and I told him it's inside time now. So we go up 2 and then we'll go over 1, 2, 3. I know, Lenny, it'll be all right. And then here we are, and we can do the 4 points of the box. just like that. So once you have those 4 points in place, then we can go ahead and graph the asymptotes. And once the asymptotes are in place, I'm going to go let Lenny play outside. So let's go ahead and get these going here. Doing my best that I can do. Looking all right. Yeah, not quite. Let's swing this side up a little bit more. All right, good enough. And then the side. We'll do an asymptote this way. All right. Okay, pretty good. All right, so now that we have our 2 asymptotes graphed, now we can actually graph the hyperbola. So it's going to go through the vertex, and then we let the asymptotes be our guide. So I'm just going to pull you over here a little bit. A little bit more that way. Oh, golly. Don't move the wrong pieces, my goodness. All right, and then we'll just indicate here. If I were doing this with pencil, I, of course, would make sure to follow the asymptote for as long as I could to indicate that, but we're working with limited tools at the moment. So, hello, there we go. All right. All right, so there we go. Those are the pieces of our hyperbola. The only thing we're missing now is the foci. Oh, actually, and to write the equation of the asymptotes, huh? So this is going to be y equals, the k value is 2 plus or minus. Our rise was a, so we're going to have 2/3. X minus -5, so x plus 5. Okay. So this is k plus or minus the slope of our asymptotes. If you're not sure about it, you can check it. So 1, 2, 1, 2, 3. So that's 2/3. And then h was -5. So that's how I got minus -5 here. Okay. Now we can go ahead and find our foci. And in order to find the foci, we need to find C. So that's what we're going to work on next. So to find C, we need to remember the relationship among A, B, and C. So for a hyperbola, A is the largest, well, not A, sorry. C is the largest distance, right? Because the foci have to be in here. So C is going to be the largest distance. So that means we're going to have the usual Pythagorean theorem looking thing. So a squared plus b squared is c squared. So we can plug in 2 for a and 3 for b. 2 squared is 4 and 3 squared is 9. And when we add those, we get 13. So that means that c is going to be the square root of 13. Since these are distances, these are always going to be positive radicals. And just to get an idea here, the square root of 13 is about 3.6. So I always like to get an idea of it because in order to graph it, I need to have some sense of, how far to sketch it. So I need to move about 3.6 away from the center for my foci. So let's go ahead and graph these. So 3.6, 1, 2, 3, just a little bit higher than 3.5. Sure. And then below, so we have 1, 2, 3.6 here. That was just 3, 1. Yeah, it's got to go further than that. There we go. Okay. All right, so that's approximately where my foci should be located. So I can see there that I started at the center and I moved up. So they have the same x coordinate as the center. So my foci have the same x coordinate. So we have -5. And then I added the square root of 13. And then I subtracted the square root of 13. So I'm just going to condense this a wee bit. There we go. So there we go for our foci. It's -5, and then we have 2 plus root 13 and -5, 2 minus root 13. All right, so we figured out all of the features of this conic section. In order to do that, we took this equation. It was almost in one of our nice forms, but it wasn't equal to 1. So to do that, again, we just divided by 36. So everything got divided by 36 to give us equal to 1. And then from there, we were able to rewrite into the form with a and b. That gave us these values. And then we kind of had this nice interplay between finding a, b, and c and graphing components to help us figure it all out. So I hope this helped you to analyze this conic section. In the next video, we're going to be analyzing a conic that doesn't start quite so close to one of our nice forms. So looking forward to seeing you then. In the meantime, I hope you have a wonderful day, and bye for now.